All right, good morning and welcome back. So we are now moving on to 10.2, which is the next section in the patterns, looking at variables and expressions. I'm going to be honest with you guys, this is a little bit of a trickier lesson, so I do recommend that you maybe watch the video twice or pause it and look at any sections again that you're not sure about, because it is a little bit trickier. But I will do my best to hopefully make it as easy to understand. So the you will be able to use for this lesson are write an expression to represent a pattern. We know we're looking at patterns. The first lesson was kind of a review. Now we're taking it to the next level for grade 7. You need to identify and provide examples of variables. The word variable means change, something that can change. So we're going to talk about that and change from a word statement to an expression. And we'll talk a little bit more about what an expression means as we move through the lesson. So there's quite a few keywords here, and some of these are going to be new to us. So a variable is something that can change. A letter that represents an unknown number. This is probably the first time that you're seeing letters in math, and that's because we're moving into something called algebra. So you might have heard or seen sometimes in math, X, that's usually the most common one that they use, or it could be any letter. So a variable is a letter of the alphabet that represents an unknown number. An expression is any number or variable or a combination of operations. Operations just means add, subtract, multiply, and divide, involving numbers and variables, okay? So here's an example. An expression could just be 5. It could be R. It could be 8t, and we'll talk about what that means when the letter is attached to the number. It could be x plus 9. It could be 2y minus 7. I know that looks scary, but don't get scared yet. We will learn more about it. Value is just a calculated amount. Now, constant is the opposite of a variable. A constant does not change. Something that's variable changes. Constant stays the same. And then finally, the last thing is a number coefficient, and that is a number that multiplies the variable. So here's an example of that, 8t. The number is the number coefficient, and t is the variable. So once again, that maybe sounds a little scary. Oops, sounds a little bit scary at first, but we will get there. There we go. Okay. So here is me breaking it down a little bit further, okay? So here we've got an example of a numerical, which is the same thing as a number coefficient. That's the 3, okay? The variable here is n. In this one, the f is the variable. It stands for an unknown number. And the 1 is the constant because it does not change. So we will use these terms a little bit more as we go through the lesson, and they will become more familiar to you. So, describe a pattern using a variable. A kitchen floor is being covered with red and white tiles. The basic design is shown here. So they're showing you this is the basic design right here. Several of the basic designs fit together, make a pattern. So we can see that. Here is the a basic one. So this is 1. Now they've just put 2 together. If you look carefully, you can see that. And then 3 together. Okay, so as we know, we're looking at patterns, so there's going to be a predictable way that these shapes are going to come in terms of the color. So it says, describe a pattern using a variable. Make a table showing the number of red and white tiles in the first 5 designs. Describe the pattern. Okay, so let's start with just doing our table. So in the first one, I can see that there are 2 red tiles and 3, 6, and 4, 10 white tiles. Let's take a look at the second one. In the second design, I can see very clearly that there are 4 red tiles. So I'm going to fill that in, 4 red tiles. And then you can go ahead and count, you can go ahead and count the white ones. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then there's 10 in this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So already my brain's going, is there a pattern there? 2, I just realized I made a mistake. 20. My brain's already going, oh, that's interesting. This was 2 and this became 4. This was 10 and this became 20. They both doubled. Interesting. Okay, well, let's keep going and see. So the next one I can see easily. There are 6 yellow, red tiles, and I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Interesting. Now, look at the bottom, 10, 20, 30. Look at the top, 2, 4, 6. Can you predict what the next number might be? If you said 8 here, awesome. And if you said 40, nice work. So here I'm going up by 2s. 2, 4, 6, 8, 10, 12, 10, 20, 30, 40, 50, 60. All right, so now this is what takes us from a grade 6 level to a grade 7 level. We need to describe the pattern, but we're not describing the pattern between the red tiles or the white tiles. We're actually describing the pattern between the red and white tiles. If you think you figured out what the pattern is, awesome, that's great. What the pattern is here is if you look here, and let's say here, and let's say here. What is the relationship between the red tiles and the white tiles? The relationship is that the white tiles are 5 times the red tiles. 5 times the red. So this is really interesting because if we look, that works. And a way to check this is just to do this. 2 times 5 is 10. 8 times 5 is 40. 10 times 5 is 50. So when we say describe the pattern, we're actually talking about, like I said, the pattern between the red and white tiles. Not just the patterns that are happening horizontally, the patterns that are happening vertically. Okay? So, let me take some of that off. The white tiles are 5 times the red tiles. So, let's go down here. This is where it gets a little bit trickier, but we will get through it. It is a new skill, so it's just something you have to practice, and once you practice it a few times, you will feel better. Choose a variable, there's that word again. Choose a variable and tell what it represents. Then use the variable to write an expression. So a variable, we're just going to say in this case red tiles, and we're going to use R to represent the number of red tiles. Remember, a variable is a letter that represents an unknown. Okay, so in this case, we are saying that 5, now this is something we should cover. So 5 times R, 5 times the variable, is the same thing as 5R. Okay, that's something that it's important for us to learn now. So if I said to you 8 times R, it's the same thing as 8R. When that R is attached to the 8, it actually just means the same thing as 8 times R. Okay, that's a new skill that we're learning, so that you probably haven't seen that before, but that is what that means. So here we're saying let R represent the number of red tiles. We know that the white tiles is 5 times the red tiles. If the red tiles are 2, the white tiles are going to be 5. If the red tiles are 6, the white tiles are going to be 5 times as many, right? 6 times 5 is 30. So 5 times R, or 5R, is this expression that we're talking about. Okay, that's what that means. Now, the reason that we need that expression is because we could just keep writing out this chart forever as long as it goes, but we want to be able to have a nice expression that can help us figure out, like, notice how we have these different designs here, design 1, design 2, design 3. If they're doing a whole kitchen floor, they might need 60 of those designs. Now, you could make a table, but that would take a pretty long time to do that. So the reason that we come up with this expression is so that we can do some quick math to figure that out. So here's a good example. How many white tiles will there be if there are 16 red tiles? So we said that our expression is 5r defines the relationship between red and white tiles. So this means the number of white tiles is always going to be 5 times the number of red tiles. So if I tell you that there are 16 red tiles, that should make you think, okay, all I have to do is multiply 16 by 5, because the white tiles are always going to be 5 times the amount of red tiles, and that will tell me how many white tiles there are. So there would be 80 white tiles. That's why it's important for us to have this expression, because it allows us to do calculations. And that's kind of what we've done here. So that was the first example. It probably might be helpful for you to rewatch this part now before doing the you try, okay? There are 4 slides for you to do for the you try. I encourage you to pause the video now and give this one a shot and then come back and see the answer. All right, so moving on. Hopefully you've done the you try already. Describe a pattern using a variable. Make a table showing the number of white and blue triangles in the first 5 designs. This question is almost identical to what we just did, but it's just a different design. So we've started our table with white tiles. The first one has 1 white, 3 blue. The second one has 2 white, 6 blue. The third one has 3 white, 9 blue. Okay, I see a pattern happening here. 1, 2, 3, 3, 6, 9. So I can fill in the numbers. This is going to be a 4, a 5, and a 6. This is going up by 3s. 3, 6, 9, 12, 15, 18. All right. Now, here's that part where we have to describe the pattern, okay? So I'm going to scooch back for a second here. That's this part right here. Let me grab a different color. Describe the pattern. The white tiles were 5 times the red tiles. Remember, I was looking at the pattern not happening here or here. I'm looking at the pattern happening this way, the pattern between the white and the blue tiles. So hopefully you discovered that the pattern was the blue tiles are 3 times the white tiles. Let's take a look and make sure that works. 5 and 15. 5 times 3 is 15. 6 and 18. 6 times 3 is 18. So yes, that works. That's how we describe the pattern in words. Now we're going to go on to the trickier part, probably the trickiest part of these types of questions. Choose a variable and tell what it represents. Then use the variable to write an expression. Okay, well, let's just do exactly what we did last time. Last time we took the category that was on the top, which in that case was the red tiles. This time it's the white tiles. So we're going to say that the white tiles is our variable. Just keeping it nice and simple, I'm going to put a W for white because that just seems easy to keep it the same letter. Now, white tiles. If the white tiles is unknown, then we know that the blue triangles are 3 times the white triangles. So if I write this down, it's going to be 3W, which is the same thing as 3 times W. The nice thing about this is you can check to make sure it works. So if the white tiles were 1, the nice thing about this is we can plug in this value. 3 times 1 equals 3. when the white tiles are 1, there's going to be 3 blue tiles. Let's try this again. When the white tiles are 2, I'm just plugging in the number for the W. So 3 times 2 equals 6. This is the number that should be in my chart for the blue tiles. Let's see if it works. When my white tiles are 3, are my blue tiles 6? Let's check. Oops. Did I make a mistake here with my math? It looks like I did. Let me just see. White tiles are 2, blue tiles are 6. Nope, that's right. Sorry. When the white tiles are 2, the blue tiles are 6. Correct. And that's what it shows on our chart right here. Okay. So let me erase some of this. Our expression is going to be 3 times W or 3W. Either is okay. All right. Now we're going to use this expression to help us find out some answers. How many blue triangles will there be if there are 9 white triangles? Well, I'm just going to plug it into my formula. My formula is 3 times W. W stands for white triangles. So here they're telling me if I have 9 white triangles, so I'm going to put 3 times 9. 9 represents W, the variable. How many blue triangles would I have? Well, I will do some quick math. 3 times 9 equals 27. So I would have 27 blue triangles when I have 9 white triangles. Now, imagine that these were in our table. 9 would be on the top, 27 on the bottom. Is 9 times 3 27? Yes, it works. All right, so that was the first section. If you're still confused, go back and rewatch the lesson, and for sure message me with any questions if you're having trouble. All right, so we're going to go on to the next part, describing patterns using expressions. So Simon creates this pattern of toothpick triangles. What is an expression for the perimeter of the triangle in relation to the base? So the base is what we're talking about right here, the bottom part, okay? So let's take a look. What is the value of the numerical coefficient? So we'll come back to that in a second. So let's take a look at our diagram. If the base is 1, the perimeter, that means total, is 3. So here the base is actually 2. What's the perimeter? We have to count all of them. So 2, 4, 6. This one got cut off a little bit. The base is 3 here. The perimeter is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's just describing the pattern. And now we'll go on to the next part. Here we're going to make the base of the triangle kind of similar to what we did with the table, but this time we're just not using a table, represented by B. Okay, so that's this part right here. We're talking about the base. Now, it says the perimeter of any triangle in this pattern is however many toothpicks are in the base multiplied by 3. So they actually already told us that. So let's check that out. So here there's 1 in the base. If I multiply 1 by 3, that's going to give me 3. And there are 3 total. Let's try the next one. Here there's 2 in the base. 2 multiplied by 3 equals 6. And that's true. There's 2, 4, 6 in there. So we know that that works, and they've told us that, so that's good. Now we have to write the expression, the tricky part. So the expression we can write is 3 times the base, or 3b. 3 times b, or 3b. So that means that whatever the base is, so in this case the base is 3, let's try it. If the base is 3 times b, which is 3, there's going to be 9 toothpicks total, which is true. There's 9 in the perimeter there. The numerical coefficient is 3. Remember, all that means is what number is in front of the variable. The variable is b, the letter. The numerical coefficient, you can just think of it because you can kind of see the word number. Oops. You can kind of see the word number in the word numerical. That's all it means. What's the number that's in front of the variable? All right. Okay, so that was describing a pattern using expression. We're going to do a couple more examples. 3 employees work at the food bank. Every day, some volunteers. Right away, I see that 3 and some. What is an expression for the number of people working at the food banks? What is the value of the constant? So the constant is the thing that doesn't change. The thing that does not change is there's always 3 employees. We don't know how many volunteers are going to come on any given day. That's why they use the word some. Okay, so constant is the thing that doesn't change. There must always be 3 employees. That can't change. They're not allowed to run unless they have 3 employees. Okay? We do not know the number of volunteers. Some days they might have 10, some days they might have 2, because the volunteers aren't employees. They're not getting paid. They don't have to be there. It's just when they want to volunteer their time. So that means that the volunteers is going to be the variable. Remember, I said the definition of the word variable means it can change. So in this case, we are going to use V to represent our volunteers, which is our variable. So to write an expression for this, we are going to say V plus 3. So there's always going to be 3 people there plus some number of volunteers. So let's say, for example, one day that there's 6 volunteers. Well, we would say V is for volunteers, so 6 plus 3 equals 9. Well, there's 9 total people there. Maybe one day there's 5 volunteers. 5 plus 3 equals 8. Maybe one day there's no volunteers. So V would just be 0 plus 3 equals 3. It's never going to go below 3 because we know that 3 employees work there every single day. That won't change. All right. Let's look at another example. Teresa is sharing some grapes equally among her 4 friends. Now, this part's key. Anytime you see the word equally among, that should instantly make you think, division. Anytime we're sharing something equally, that's division. So, what is an expression for the number of grapes each friend gets? Now, we know she has 4 friends. Do we know how many grapes she has? No, we don't. It just says some grapes, just like it said some volunteers. So that's my hint right away, that if it says some grapes, that I know is going to be my variable because I have no idea how many grapes there are. They didn't tell me. So if you read that, I wrote that here. We do not know how many grapes she has. However, we know that however many grapes she has, she's going to share them between 4 friends. So grapes in this case is the variable. So we're just going to use G for grapes. We don't know how many grapes there are. But we do know that she's going to share them between all of her friends. So, like I said, equally share always signals division. So in this case, the expression is G divided by 4, because however many grapes she has, she's going to split them between 4 people. Let's say, for example, that she has 20 grapes. So G is grapes. If she has 20 grapes, I'm just substituting 20 for G. Divided by 4, each friend is going to get 5 grapes. Let's say she has 26 grapes. 24 grapes. Divided by 4, each friend's going to get 6 grapes. All that you need to do when it asks you to write an expression is this part that you see right here. Okay? Couple of you tries below. See how you do. Give it a try and then come back. I've kind of helped you try and break it down a little bit here to figure out the answer. All right, a group of friends are talking between classes. 2 friends leave the group. A group of friends. Well, a group doesn't tell me how many. So instantly that makes me think, okay, the group of friends is going to be my variable. Total number in the group of friends, G. I don't know how many people are there. But I do know that 2 friends leave the group. How many friends leave the group? 2. So when I say leave, now I need to think, would that be multiplication? No, that would make it bigger. Would that be equally sharing something? No. Would that be adding something? No. Would that be subtracting something? Yes. So your answer would be the group subtract 2. We don't know how many friends are in the group. That's what the G represents. And the -2 represents the 2 friends that left. The 2 would be the constant, doesn't change. The G, would be the variable because it does change. We don't know how many people are in the group of friends. Okay, next one. You walk into a store to buy 4 boxes of cereal. What is an expression for the cost of 4 boxes of cereal? Okay, well, I need 4 boxes of cereal. Nowhere in this equation does it say anything to me about how much they cost. So that tells me right off the hop that the cost is going to be my variable because they didn't tell me. I don't know. You're basically just looking to say what information did they not give me. So identify which information you do have. That's the first most important thing. Total number of cereal boxes you want to buy. It says in the question, you want to buy 4. Cost of a box of cereal? No idea. They didn't tell us, so that's our variable. I just did C for cost. So expression time. Am I sharing these boxes of cereal? No. Am I subtracting the cost? No. Am I adding the cost? Well, I could be adding them, but then I would have to add them up individually, so that doesn't work. Here we're actually multiplying. So there's 2 ways you could write this. You could have written 4C or 4 times C. Those mean the exact same thing. So that is the end of the lesson, guys. Once again, I encourage you to go back and look at anything that you don't understand. There's a couple key idea slides I'm going to go through here, but this is kind of one of those lessons where you just have to keep practicing to get a good hang of what's going on here. So key ideas from this lesson that you should understand. A numerical coefficient is the number in front of the variable. Remember my trick? Number. Numerical. They sound the same. The variable is the letter. Anytime you see a letter X, B, Y, Z, T, C, W, any letter in the alphabet, that's your variable. Finally, the constant is just the number. Now look, the constant is not attached to the variable. Here, they're attached. In this case, it's not attached. So the constant is when you have like subtract 1 or plus 1 or plus 3 or something like that. The constant is when the number is not attached to the variable. When it's attached to the variable, it's called the numerical coefficient. When it's not attached, it's called the constant. Okay? Those are just some technical terms. Any letter can be used as a variable. Okay, this is important. Any letter can be used as a variable. To write a pattern or expression, choose the variable and tell what it represents, right? We have the white tiles, the blue tiles, the grapes, the group of friends, all of those things. Describe the pattern using the variable numbers and operations. Remember, operations is just, are we adding, subtracting, dividing, or multiplying? Time to practice. It is essential that you go through and do the textbook questions before you try the workbook. You might be tempted not to do them, but it's important that you do this and then check your answers. Super, super important. If you go on to the workbook and you haven't had any feedback, meaning that you haven't looked in the textbook to see, am I doing these right, and checked your answers, You're going to struggle with this, okay? So super important. Do the textbook, check your answers, make sure that you are happy with your level of understanding before completing the workbook. All right. Okay. Good luck with this lesson. If you have questions, please don't hesitate to ask me. I would be happy to help you, and I would rather you do that than try the workbook before you're ready. All right. Good job, you guys.